Greetings and welcome to Raven's Roost Forge. This is Tate, your host, and today we're going to build a stump anvil using an old sledgehammer. Let's get going. For this build, we're going to be using an old sledgehammer, a railroad spike, and a bolt. The first thing I want to do here is lay out where I'm going to cut this sledgehammer head apart. I want as much steel as possible, so I'm laying it out so that the cut line is just above the eye. Since this is a square sledge, the layout is pretty simple. If you have an octagonal shaped sledgehammer head, which is more common, then it'll be a little bit more layout, but should still be pretty easy. Next, we need to determine how much of the spike we're actually going to be using for this build. I chose to mark out about 3 inches, which should be more than enough when we embed it in the stump. In the US, the most common size rail spike is 5/8 square. A 7/16 inch bolt is about the largest that the rail spike will accommodate. This is a grade 5 bolt, which is a higher quality steel and is heat treated. You may have noticed that in the first few videos I used a clamp-on vise and a folding workbench. Now I did this just to illustrate the fact that those entry-level tools were more than adequate for this work. But if you have more robust tools available, I suggest that you make use of them. Okay, moving on. You can see here that I'm just cutting off the part of the spike that we're going to be using for this project, and then the rest will go in the scrap bin for some other project. Next, we're going to go ahead and cut up the sledge so that we have the material we need for the actual anvil itself. Just as in the previous video where I was modifying the forging hammer, what I'm going to do is cut shallowly around, following as closely to the marks as possible, and then cut deeper and deeper until we get all the way through. This way we can keep the cuts as square as possible. A 4.5 inch angle grinder disc is not going to make it through in one cut anyway, so this turns out to be the most effective method. So in just a moment you'll see that I cut the particulate counter. You can see the amount of pollution levels in the shop with all this cutting, so it's important to make sure you wear a respirator. Since I can't quite reach to the center with those cutting discs, I'm going to finish off with a hacksaw. Now if you have a hammer head that's fairly hard, then it's not going to cut very quickly with a hacksaw. But most hammers, particularly sledges, are not hard enough that you won't be able to get through it with a handsaw. Here you can see that we got a relatively flat and even cut, but we're going to need to do a little better than that, so I'm just going to take a hand file and I'm going to file down that nub in the center and then try to start squaring up and flattening out the base. This filed fairly easily because it's somewhat soft. If your sledge is too hard to file easily, you can place it bottom down into the forge and then heat it up until the bottom gets a nice blue-gray color. If you frequently dunk the face in water while you're doing this process, you can preserve the hardness on that side. You see when I place the block on the milled portion of the vise that there's a wobble, so it's not flat yet. I'm going to use a flap disc to go ahead and try to flatten that out a little better. I do think that it's a good idea to start out with a file though, because it's easy to make it actually more uneven when you're using a power tool like this. So I'm actually trying to remove metal mostly in the middle because that's where there was a high spot. Since I have a belt grinder available, I decided to use it to flatten this out a little better. But if you don't have one, then you can just go back to the file to get it the rest of the way flat. In fact, you'll see in just a moment that I still use the file to do the last bit of flattening and squaring up of the base. The technique I'm using here is called draw filing, and you actually use the file kind of perpendicular to its length rather than pushing it long ways as you normally would. This is an excellent technique for getting a flat and even surface. Another good trick is to make sure that you approach the work from different angles. Now when I place that block down, it feels nice and solid with no rocking. Next we're going to tackle the spike. We need the top of this to be flat and square as well. Otherwise, it won't be square when it attaches to the anvil, and then the anvil won't be square to the stump when we drive it in. We also want the spike and the anvil to mate together with no gaps, because that will increase the strength at that joint. You want the top of that spike to be fairly level and fairly square, but it doesn't have to be absolutely perfect, so I'm just eyeballing it. Of course, you want to make sure that the surface you're using is level, so I'm using a digital inclinometer to make sure of that. Railroad spikes typically have 2 parallel sides and 2 beveled sides where you drive it in, so I'm just going to take a grinding disc and bevel those opposite sides so that it drives a little easier into the stump. Now we're going to pre-drill that stump, so this is not really critical. You could probably skip this step if you wanted. So now you can see that we've got a shallow 4-sided taper. That will drive a little easier into our stump. Next, I'm just going to remove that grinding disc and then switch it out for a paint stripping disc. And we're just going to get off any rust and gunk off of that spike. If you don't have any surface conditioning discs like this, then you could easily do it with a flap disc. Just remember, we're trying to just clean it off, so don't remove too much metal. I'm also going to use that surface conditioning disc to make sure that we're down to bare metal on the face of this anvil. That way we can see what we're dealing with. You can see that there's a lot of dings in the face, so we're going to have to flatten those out. I'm just draw filing until it's roughly flat, and then I want to check the squareness to the base. I'm being pretty anal about making sure that the face is square to the base, but it's not really that critical. As long as it's fairly square, then you'll be able to forge on it easily. Now that I know the face is square to the base, I want to get the rest of those divots out. I'm actually going to do it with a file, moving fairly slowly because I don't want to wreck the squareness. If you're not as concerned with squareness as I am, then just use a 4.5 inch grinder to get your anvil face relatively flat. Considering how chewed up the face was on this sledge, it took a lot of work to get it flat with just a file, so I cut out a lot of that footage so I wouldn't bore you. So I'm just going to flip it over, test to make sure that it's fairly flat, and that's looking pretty good. Now that both the base and the face are flat and square, I'm just going to clean off the sides and round over any sharp edges using a flap disc and a conditioning disc. Here you can see I've gone back to the face of the anvil, and I'm just going to use a surface conditioning disc to polish it up a little and then round over all the corners. You always want to make sure you have at least a small round over on any forging surfaces so that you don't mar your work with the edges. That's looking good. Flat, polished, with nice roundovers on the edges. This part isn't strictly necessary, but I figure if I'm going to do it, I may as well do it right. So I'm just going to take off the burrs on the base and put just a tiny bevel. Just double checking to make sure that everything is still square, and it is, so we can move on. The spike and the anvil will be attached together with the bolt I showed earlier, so we're going to need to drill and tap in the center of this anvil base. I'm using a center finder and a scribe to get as close to the exact center as possible. If you don't have a center finder, or you're using an octagonal sledge, then just draw a line opposite corner to opposite corner using a straight edge. Do this a couple of times and that will give you a rough center. Now that we've got center, we want to put a punch mark there so we can index our drill bit when we drill. And now we've got to do the exact same process on the end of the spike. When you're trying to find center like this, using a center finder or even a straight edge, you want to actually kind of go all the way around. So doing 4 lines instead of just 2. This way, if you make mistakes, you're likely to kind of cancel them out. So we're going to put a block down so that we don't mar the top of our work table. And then we're going to put a punch mark in the center of the spike as well. The next step is to drill out the base of the anvil. I'll show you how to do it using a hand drill and a drill guide first. Start with a small bit, use lubrication, moderate pressure, and then go slowly. A drill press is going to be by far the better option for this. So I'm going to do the rest of the hole that way. Mount it securely in a vise and then make sure that the base is square to the drill bit. I'm using an inclinometer to do that. What you're not seeing is that I was using that brass hammer to tap it into square with the drill bit. Make sure that the vise is clamped down somehow, and then we're going to drill it out. It's always worth the time to properly clamp down your item on the drill press. When you try to hold it down yourself, then you're asking for an injury. I drilled down about 3/4 of an inch so that there's about 3/4 of an inch of threads to hold the pieces together when it's done. Once you have the right depth, you want to step up the size of the drill bit until you get to the size needed for the tap that you're going to be using to thread. It's worth noting that even though these clips appear to be in real time when I'm doing the drilling, that they're also sped up to reduce the tedium. So keep that in mind, that you want to actually run your drill bits very slow, and you want this process to be done slowly and carefully. Once the base of the anvil is drilled out, we need to perform the same operation on the spike. Here I'm using an inclinometer and a machinist square in order to get the spike square to the drill bit. Just as with the anvil base, you can mount the spike in your bench vise and drill it by hand. It's just going to be more challenging to get a square and plumb hole. Again, once you have the correct depth, step up the size of the drill bit until you get to the size you need for tapping. For a 7/16 inch bolt, we want a 25/64 or 13/32 hole. If you're using metric bits, that would be about 10 millimeters. When I tap the threads, I use a thread guide to keep the tap straight. This isn't necessary though, just do your best to keep the tap plumb and you'll be okay. Whenever you're cutting threads, make sure that you lubricate the cut, and if you're using a straight flute tap like the one I'm using, make sure to reverse every half turn or so in order to break the chip. Otherwise the tap is going to bind and likely to break into the hole. This is a tapered tap, so you're not going to be able to thread the hole all the way to the bottom. So you want to drill a little deeper than necessary in order that you can get the threads you need. And then when you're done threading, always make sure that you check that the threads actually work. Then you just want to repeat the procedure to thread the spike. Again, always check your threads and make sure that they work. Next is to cut the head off of the bolt so that we just have the threads. This is a hardened bolt, but a hacksaw should still cut it easily. You probably couldn't tell what I just did there because the footage is sped up, but I took a little wax and rubbed it on the blade in order to lubricate it so that it cuts smoother. Now that the bolt head is cut off, I'm just going to use a file to clean up that end. We need to be able to thread the bolt in and tighten it, but now that it has no head, that's a little tougher to do. So I'm just going to cut a little slit in the end so that we can use a screwdriver. You could always leave the bolt head on and then thread it in and tighten it down and then cut the bolt head off. That's probably actually a little easier than the way I elected to do it. There's not much left other than to thread the two pieces together and then tighten them down. Since the rail spike has a square cross section, you can easily get an adjustable wrench on there to tighten it up. Torque it down pretty tight to get the most strength out of the joint. Use a little thread locker if this is your final assembly. If the sledge that you started with was fairly hard and the temper didn't get ruined as you are doing the build, then this bad boy is pretty much ready to use at this point. Since the sledge I started with was fairly soft, we're going to need to heat treat it in order to get the most out of it. So next video I'll show you how to do that, as well as how I constructed the base to mount it on. So I hope you enjoyed this video and you learned something. Don't forget to like and subscribe, and I'll see you next time.